for those state tests. Thanks, Pauline. Thanks, Tiana. Thanks, Aaliyah. Dominic, Memory. Thank you for getting there. Ethan Wolf, Vivian, Haley, Noah, Jasmine, Rocco, Noah, and Carrie. Thank you, thank you, thank you. So getting in there, counting atoms. It's not as easy as I thought it would be for you guys, but it's not. You just have to kind of look at the pattern here. All right. Pretty good. Half about yourself. How about yourself? Thank you. I like it. I like it. I like what I'm reading here. All right, so I'm going to clear the chat real quick. So, and then I'm going to put that link in there. So we've got 51 people. So, like I said, we reduced the size of our class, so we have a new teacher in here. So some people went into the new teacher. So I have a lot more time for you. Doing pretty good. Oh, good. I'm glad to see that, Madison. Okay, so let's start this. We got 18 people. Thanks, Kobe, for getting in there. Jordan, Luriana, Jacob. Thank you, guys. All right, so counting atoms in the formula. And the law of conservation of mass is really important. So that is what we're talking about. So when you have the reactant side and the product side, I'm going to turn my face off here for a minute. I'm going to stop sharing the webcam. So when you have the reactant side and product side, what you start with the number of atoms and the kind of atoms have to be the same. So if you start with a hydrogen, you'll end up with some hydrogen. If you start with a chlorine, you'll end up with some chlorine. But if you start with some chlorine and end up with sulfur, that can't happen. You can rearrange atoms as long as you've got atoms to rearrange, but you got to have some to rearrange. Okay, so again, this is the most important thing here. The law of conservation of mass states that chemical reaction mass is not created or destroyed. This means the mass you start with, the reactants, is the same as the mass you end with, the products. And again, it also means that you have, if you start with an aluminum, okay, oops, sorry, aluminum, you end up with an aluminum, not carbon. Okay, you don't go from aluminum to carbon. We're going to add a couple. So we're going to be talking about the different kinds of reactions that we have, but you got to remember that the elements look the same. The law holds true for chemical and physical changes. All right. So elements, any substance that cannot be broken down into simpler substances. I know I'm going way back in the day. So examples H, Ne, F, B, He, and O. Now, you got to remember when I write something, if I write H, am I writing on this? No, I'm not. Okay, let's do this. What happened there? Back up. Back up. I hit too many things. All right, so if I have something that looks like this, H, Br, think of it as a comma between the capital letters. Okay, so HBr is not one thing, it's two things, and the capital or the small letter goes along with the capital letter. So this is one thing, this is one element, and this is one element, so it makes two. All right, so that is what you have to look at, because we're not going to have commas in here, right? We're not going to have commas, so we have to look at those. So Anything that's by itself, H, N, E, F, B, H, E, and O are examples of an atom. A molecule has a subscript if it's the same element, or it's combined with another element. So H2O is hydrogen and oxygen. Capital C, capital O, there are two here. That's two elements there. This has two elements. Just means that there are four of the hydrogen, two of the oxygen. And a compound is substance that's formed by two or more elements bonded together to set ratios. So we can have a molecule. Notice that the molecule here, oxygen, is not a compound because it's two oxygens connected together. If I were to draw this, that's terrible, right? So this is a molecule, but not a compound. Compound is two or more elements different. So here is H and O. Okay, so that's what we're talking about. Let's see if we understand this. Go next. Okay, so here's a quiz question for you to see if you've been paying attention. All right, table salt. Is it an element, NaCl, a compound, or a mixture? Is it, so remember what we just read, Na metal and Cl, which is a gas. It forms to make a salt. Running out of time. Oh, all right. So most of you guys said it's a compound. A mixture, we don't write mixtures that way. This is a chemical formula. It's not a mixture. So NaCl. So I can think of it this way if I were to put a comma between the Na and the Cl. There are two different elements. Na is one element and Cl is two elements, so it would make it a compound. Now Cl2 is a molecule. It's one element. It just happens to be bonded to itself. All right, so let's do this next slide here. Elements are made of what? Many types of atoms, the periodic table, one type of atom or molecule. So the element, let's call the element, okay, so we have an element here. Go Ne, capital N, little e. Okay, what do we call that? That's an element. So you should have said one type of atom. Did you say one type of atom? Uh-oh. Many types is a compound. All right, so again, compounds are like H2O. Okay, compound is, all right, but this Cl2, oops, I'm gonna keep hitting my Cl2, keep hitting my button there. Cl2 is one element, they're just two of them, they bonded together. That's still an element. It's one thing. Capital letter and little letter will tell us that it is one element. Okay, sometimes things like carbon have only one letter. That's one element. Okay, let's do the next one here. Are these molecules or compounds? All right, oxygen, O2, N2. If it's the same molecule, okay, if they are the same, and they are. So this is a molecule. Compounds would be like NO, nitrogen dioxide, NO2. All right, see how you guys did here. Okay, whoops. Okay, they are molecules. Are these molecules or compounds? They are molecules. What was the question asked? Let me read. Are these molecules also compounds? Oh, I'm sorry. This is a no. They are not compounds. Sorry, I read the question wrong. This is a no. Okay. The molecules, in order for them to be a compound, they have to have two different elements at least. So it's not the same thing. I'm glad we went over this. Which of the following can be broken down into something simpler? All right. So an element like the letter C cannot be broken down. There's only C. This CH4. And a mixture we're not even talking about. Okay. I don't know why they put chemical formulas. So this is the only thing we can talk about, that this is the compound is the only thing we have in here. All right, let me do this. Close that out. An element, which of the following cannot be broken down? You're right, elements cannot be broken down. All right, we're going to skip this one. Okay, so let's take a look at, so we kind of reviewed that. Guys are a little rusty, that's okay. Subscripts and coefficients. Okay, so the chemical formula for H2O is that. So we have, if we have two molecules of H2O, that's our coefficient. So this number right here is our coefficient. It means we have two molecules of H2O. The little 2 tells us, that's the subscript, tells us that we have, for each molecule, we have two hydrogens. There's 1 and 2. 1 and 2. Okay? So subscripts are the small number here. The coefficients are the ones in the front. We cannot change the subscripts. Okay, they come that way, right? But we can add the coefficients. And this is called stoichiometry. So it's talking about balancing equations. Balancing equations, they get that name from a lot of stuff here. All right, next slide. All right, subscripts are numbers that are written below the chemical symbol. Okay, so N2. All right, there are two, the element N, there are two atoms of that total, and it's an element. It's also a molecule, right? Because it's in a pair. If it was just carbon, all right, and it doesn't have a number by it, it would be an element, not a molecule. This is a formula for C6H12. This is sugar. There are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So you can also think of the, when I think about this, you can also think about this as a kind of comma. When you have numbers, all of them have numbers. So that's 1, 2, 3. There are 3 different elements. Okay, total of 24. So 12 and 12 is 24. It's a compound because there are at least 2 elements. So there's 3 elements here. H2O, 2 atoms of hydrogen, 1 atom of oxygen. It's a compound. And there are 2 elements. So, right, so that's how we kind of figure those out. We need to do that in order to balance equations. Next, coefficients are the number in front. Now, what that does, it multiplies. So we've got a compound of water, H2O, and I've got 4 of them. So if I'm drawing that, I have 4 H2O molecules. And again, so now I have 4 times 2. So if I think about this, 4 times 2. So if I think about that, I got to go 4 times 2 here. That's 8. and then 4 times 1. It's like the distributive law, 4 times 1. So that's 4. So there are 12 total atoms, 2 elements. It's a compound. Oh, there are 4 compounds. There are 4 compounds together here. So the 3HC, so again, there are H, C, and O. So that means they're H, C, and O. That's how we break those down. This 3, okay, times 1. 3 times 1 is 3. Carbon, 3 times 1 is 3. And oxygen, 3 times 3 is 9. So that's how we're kind of figuring these out. So when you have a coefficient and multiplies everything out. Okay, let's see if we got here. Okay, see if you figure this out. Oops, got to go back one. All right, how many elements? Okay, so think about this as your elements here. Can I do this thing here? 2 elements, only 2 elements in here. How do we do? Boop. Let's get rid of that. All right, so many of you, I'm not sure where, oh, okay, sometimes people think that little E is an element. So remember, it's the capital letter and little letter. All right, how many atoms are present in this symbol? How many elements are present if there is no subscript? Okay, so that would be like the letter H. Okay, there's no subscript. So how many elements? And remember, we put a 1. We don't have to put that 1 down there. So let's see if you guys got that one right. Should have 1. How many got? Oh, good, 1. So if they write it, it's again like X when you're talking about chemistry. When you're talking about algebra, X is really there's 1 X there. Right, how many atoms in this particular compound? How many atoms of iron? I'm sorry, it says atoms of iron. How many? Fe is your iron atom. Fe is your iron atom. So Fe with that subscript of 2, how many? Hopefully you put 2 down. Good. Hey, you guys are getting really good. The 3 goes with the oxygen. How many different elements in this particular, how many different elements? Okay, so let's do this. That's a comma. That's a comma. That's a comma. That's a comma. Those are all capital letters. So 1 hydrogen, 2 carbon. Uh-oh. 3. But because these are the same, they wrote it kind of weird here because it should be C2. So there really is 1, 2, 3, 4, not 5. 1, 2, 3, 4, 5. So because you have the carbon twice, that was messing you up. I'm sorry, that probably did. Probably did. All right, so just 3. So 1, 2, 3, and then the hydrogen. See, they have hydrogen as well. They sometimes do that. And again, I won't be trying to fake you out like they did here. I should have taken that slide out. All right, so how many total atoms? So we got to count them all up, right? Total atoms, right? So we know that we have 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. So add them all up. Total atoms, total. Okay, could have gotten 7. 7? Did you get 7? Oops, got to go back down to there. Good, good. You did get 7. All right. Okay, so we're going to stop right there. Okay, just some practice. I know it's, again, it's difficult to do. That's okay, Pauline. Kicked you out. Oh, sorry, Kobe. That happens. Well, let's go to this Nearpod assignment. This one's going to be, we're going to use those skills. Again, we're going to practice a couple different skills here. All right. We're going to use those skills to help us balance equations. Okay. And I know this is maybe new for some of you. Don't worry about it. We're going to be practicing it today and tomorrow, and we'll be practicing it probably forever. All right. So, and again, you'll get more practice when you get into biology as well. I'm going to put this in the shared notes as well. Thank you guys for getting in there. I know it's like hopping around, hopping around. I wish it was all one platform, but it's not. Okay. There's the Nearpod. Okay, and again, I'm helping you with this because your exit quiz is this assignment. This assignment, part of this assignment is your exit quiz. And again, you can always see me at 3 o'clock. We can work these together. I like doing this stuff. If you like doing this stuff, maybe chemistry is in your future. All right, so if you could jump in there, I appreciate it.